Okay, 5 part 1 is one of those r sine theta plus alpha questions. In this case it's a cos theta. So first job is writing the addition formula for r cos theta plus alpha, which is going to be r times cos theta cos alpha minus r times sine theta sine alpha. And that is going to be what we're going to write 4 cos theta minus sine theta as. We want to write that like this, but this equals this expression, so we can say that 4 cos theta minus sine theta can be given like this. And this way is going to allow us to work out what sine theta, what alpha and r are. So in order to find out what alpha and r are, we're going to set, first of all, theta to be equal to 0. Because when theta equals 0, sine theta disappears, and cos theta equals 1. So we're going to have 4 times 1 here on the left, which is just 4, and on the right, we're going to have r. Cos theta, as we said, is 1, so r cos alpha. And that's the same as saying that cos alpha is equal to 4 divided by r. Similarly, when we let theta equal 90, this time cos of theta is 0, cos of 90 is 0, and sine of 90 is 1. So this time this bit's going to disappear, and we're going to have minus 1 is equal to 0, because we've got a cos theta here as well. 0 minus r times 1 times sine alpha, so minus r sine alpha. The minuses can go, and that leads us to being able to write that sine alpha is 1 over r. Now what we can do is link this to a right angle triangle, where in cos theta we've got that cos theta is the adjacent over the hypotenuse, and that sine theta is the opposite over the hypotenuse. So if I draw a right angle triangle, then 4 is my adjacent, 1 is my opposite, and r is my hypotenuse, and therefore r is going to be, using Pythagoras, 1 squared plus 4 squared, so that's root 17 for r. And alpha is going to be the inverse tan of the opposite over the adjacent, inverse tan of a quarter. And the inverse tan of a quarter is 14.0. So in answering the question, we get that 4 cos theta minus sine theta can be written as root 17 cos theta plus 14.0.